Daniela Diaz, and today I'm going to explain node analysis with voltage sources. When you have a voltage source but no nodes related to the current, then you have to use node analysis. We have two cases. In the case number one says, if a voltage source is connected to a reference node, then the voltage source is equal to the voltage of the node. In case number two, if a voltage source is connected between two not-reference nodes, then you have a supernode. Now let's make an example. In here we have a circuit with two voltage sources, and the first thing we have to do is to find the nodes. Here is node number 1, here is node number 2, and this is number 2. And this is node number 3. So now that we have found the nodes, let's remember the cases. Case number 1 said, if a voltage source is connected directly to a reference node, then the voltage source is equal to the voltage of the node. And now we see that node number 1 is connected directly to this voltage source. So now we can say that node number 1, let's say voltage number 1, it's equal to 10 volts. Now let's analyze the other nodes. Case number 2 said, if a voltage source is connected between two not-reference nodes, then you have a supernode. Now we have in here a voltage source connected between two not-reference nodes, so it means that this is a supernode. Let's not forget to put a reference here that is called Earth. So now we have the voltage, the supernode, and this case number 1. Now let's write the equations of the nodes. In here, the supernode has two equations that we have to remember always. We have to analyze the equation that is coming in or out the node, and the equation that is inside the node. First of all, let's do the equation that is going in or out of the things that are going in or out of the node. So we have node 2 minus 0 divided by 8 plus. Let's remember that when we want to get an equation, we do this little rule. So it's the node we are parting from minus the node we are getting to divided by the resistance. So it will be N2 minus 0 divided by 8 plus N2 minus N1 divided by 2 plus N3 minus 0, because we're going to not a node, so it's 0, divided by N3 minus this node, 1, N1, divided by 4, equals 0, because there is nothing entering this node. So now we have one equation of the supernode. We need the other one. In order to get the other one, remember, it will be always like this. This node side minus the node of the negative side equals to everything that is in there. It could be a dependent source or anything, but it will always be positive minus negative equals to the number of the voltage. So the equation will be N2 minus N3 equal divided by anything, because we can divide it, equals to 5 volts. So now we have to answer these equations. You can answer whatever you like. You can use matrices, or you can use, as I do, a TI inspired task. So let's do it. So now that we solve these equations, we get that, as I said, voltage number 1 is equal to 10, voltage of the node 2, node 1, equals to 8.0952. Remember to always put 4 numbers after the 0 in order to have more, to be more exact. And voltage number 3 is equal to 3.0952 volts. So now we have the voltage of every node. So that's it. That's how you answer nodal analysis with voltage source. Thank you.